Hello students, welcome to class 10. So today we are going to start with our first chapter in physics, that will be light, reflection and refraction. In this chapter we will be studying about some of the effects produced by light such as reflection, refraction, etc. etc. So basically what's light? Light is a form of radiant energy. I'm going to write here. Light is a form of radiant energy that is, it is emitted by excited atoms and molecules, which can produce sensation in human eye. This is the scientific definition of light. Light is a form of radiant energy, that is, it is a form of electromagnetic wave. Light is basically a wave, form of radiant energy that is, it is emitted by excited atoms and molecules, which can produce sensation in human eye. Now, we are watching everything around us just because of light, but we cannot observe light, we cannot see light. I'm observing this board because light is coming from that direction, it is getting reflected and coming to my eye, and that light is producing some sensation in my eyes. Fine. So let's move into it. Several things will come. First of all, I'll be talking about rays. What are rays? Generally we assume that light follows a straight line path. Light moves in a straight line path. That straight line path is known as rays. Straight line path followed by light is known as rays. Light will be moving in straight line path. So this is a ray coming from this direction and going towards this direction. Fine. Next term comes as beam. Collection of rays is known as beam. Collection or group of rays. For example, collection of rays. Right? Now, beam can further be divided into three sections. Beam can further be divided into three sections. I'm writing here. First is beam. Beams are of three types. Parallel beam, convergent beam, and divergent beam. So beam is basically collection of rays. Fine. So parallel beam, in which all the rays will be parallel like this. So this is parallel beam. All the rays are moving in same direction. Convergent beam. Convergent means all the rays will be converging at a point. Fine, like this. These are converging at this point, moving towards a single point. Divergent beam. Rays will be diverging from a point, diverging away, like this. Fine. So this is the point. Rays will be moving like this. These are divergent beam. I hope you are getting it. Fine. Now, next comes as object. We'll be talking about objects, images, optical elements. All these things will be covering one by one. So first is object. Now what is an object? Object is simply intersection point of incident rays. Intersection point of incident rays. Now, further this object can be divided into two segments. First is real object and second one will be virtual object. Keep writing with me. Real object. Real object means incident rays will be incident rays will be diverging from a point, and that point will be known as object. Incident rays will be diverging away. Fine. Let's say if this is your object, if this is your real object, then rays will be diverging away. These rays will be reaching your eyes and you will be able to see this object. This is real object. This is what? Real object. Now what about virtual object? Incident rays appears to converge at a point. Incident rays appears to converge at a point. Fine. I am drawing here. These are incident rays. They appears to converge at this point. These are not diverging away. This is real object. Object will be placed at that point. But here, this is a virtual object. Incident rays are appearing to converge. So this is virtual object. Right? Now, next is image. Object and its image. Now, light shows certain phenomena like reflection and refraction. So, incident rays are rays before reflection or refraction is taking place, and image will be the intersection point of all those rays which are coming after reflection or refraction from any optical instrument or optical element. So, image. Image is basically intersection point of intersection point of reflected or refracted rays. Intersection point of reflected or refracted rays, that is after reflection or refraction. Again, images are of two types: real image reflected or refracted rays. Reflected or refracted rays will be actually converge at a point. They will be actually converging at a point after reflection or refraction. Fine, like this. If these are reflected or refracted rays, they are converging at this point. Therefore, this object is known as, this image is known as real image. Fine. Next is virtual image. Reflected or refracted rays appears to diverge from a point. These are reflected or refracted rays. Fine. So virtual image means reflected or refracted rays appears to diverge from a point. If this is the point, appears to diverge like this. Appearing to diverge. So this is virtual image. I'll be taking some examples. What are real object, real image, virtual object, virtual image. Fine. One by one we'll be going through it. So first of all, you have to understand the definitions. Fine. I hope you're getting it. Now, so this is about object and image. Now, our next topic is reflection. Reflection. Now, suppose incident rays are moving in certain medium, and after reflection or refraction, if they comes into the same medium, or you can say after meeting the optical element, if they are returning to the same medium, then that phenomenon is known as reflection. Fine. So reflection, I'm writing definition. If light rays comes into same medium after meeting optical element. Optical element means mirror, slab, etc., etc. After meeting optical elements, if light rays comes into same medium after meeting optical element, then this phenomenon is known as reflection. I'm taking an example here. Suppose this is a mirror. plane mirror. Fine. Now this side is polished. If you observe a mirror, one side will be reflecting and one side there will be some polish or a paint will be there. So this is painted side, or sorry, this is painted, and this side is polished. Fine. Now there is an object here. Fine. From object, infinite rays will be emanating or diverging. I am taking only single ray. Let's say this ray is like moving like this. Rays will move in a straight line. They are meeting this optical element and they will move like this. They are returning back to same medium, in same medium. So this phenomenon is known as reflection. Fine. Again, reflection is of two types. Reflection is of two types. First is regular reflection. Regular reflection. Right. Suppose this is a mirror, this is painted and this is polished. Some rays are coming like this. These are incident rays. Now after reflection, this ray will move like this. This ray will move like this. And this ray will move like this. Coming from a single direction and moving in a single direction. Fine. So this is regular reflection. If light rays come from a single direction and moves in a single direction, then that reflection is known as regular reflection. Sorry. Right. Next is irregular reflection. Irregular reflection. Right. Suppose your polished surface is like this. This is your polished surface, irregular surface. Suppose light rays are coming like this. Parallel beams. Now this ray will move in this direction. This ray will get this direction. This ray. Now see, these rays after reflection are not parallel. Here they are parallel to each other, but here they are not parallel to each other. So light is in all directions. It is getting reflected in all directions. So this is known as irregular reflection. Fine. I hope you are getting it. Fine. Now, let's move on to plane mirrors. Plane mirrors. By mirror I mean reflecting surfaces. Fine. Plane mirrors. This is a plane mirror. Okay. There is an incident ray. This ray is incident ray. It is coming from some object. It is striking the mirror here. I am drawing a perpendicular line here. I am drawing perpendicular. This line is perpendicular to mirror. Let's say angle, this is normal. Perpendicular line at a point is known as normal. Let's say incident ray and normal. Angle between them is I. And this ray, after getting reflected, is moving in this direction. This is reflected ray. Reflected ray. And let's say angle between reflected ray and normal is denoted by R. I equal to, this is known as angle of incidence. Angle between incident ray and normal at that point is known as angle of incidence. Right here, angle between incident ray and normal drawn at point of incidence. What do you mean with point of incidence? This is point of incidence because this ray is striking the mirror here. So this is point of incident. Fine. Similarly, R. This is known as angle of reflection. Angle between normal and reflected ray. Angle between reflected ray and normal drawn at point of incidence. Fine. Keep writing with me. Now next comes laws of reflection. Laws of reflection. First is, there are two laws. First law says the incident ray normal and reflected ray all lie in same plane. Incident ray, reflected ray and normal. All three are lying in same plane. Fine. Second law is angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection. This angle will always be equal to this angle. Fine. So angle I equal to angle R. This is second law of reflection. Are you getting it? Note it down. this angle, I am denoting it by, let's say, theta. That theta is known as glancing angle. Glancing angle of incidence. Glancing means angle formed by incident ray with mirror. Here I am taking angle formed by incident ray and normal. That is known as angle of incidence. But this is known as glancing angle of incidence. Let's say this is theta, and let's say this is, I am denoting it by, let's say, phi. This symbol is denoted by phi. So phi equal to glancing angle of reflection. Angle formed by reflected ray with mirror. Okay? Note it down.